In this video, we will deal with the linear equations and how to approach problems of the linear equations. Equations. An equation is a statement with an equal sign, stating that two expressions are equal in value. Examples. An identity is an equation which is always true, no matter what values are substituted. Examples. Solving an equation means finding the value or values for which the two expressions are equal. This value or values will make an equation true or correct. See the examples. Solve the following equations. X plus 4 equals 2. In order to get x on its own, start by isolating x on the left-hand side of the equation by subtracting 4 from each side of the equation. This will remove the term plus 4. You can get x on its own and find its solution. This answer can be checked by substituting x by minus 2 into the original equation. Very often, solving equations requires more than one step, but the method is still what you do to one side of the equation, you must also do to the other side. In this equation, isolate 6 times y by adding 6 from both sides. To work out the value of y, divide both sides by 6. Therefore, y is 3. In this equation, start by subtracting 1 from both sides. Now, we will need to divide by 3 and multiply by 4. The order does not matter. Multiplying by 4 and dividing by 3, we get t is 16. Some of the equations which you will be asked to solve may include brackets. In these cases, you need to expand the brackets before you can solve the equation. Expand the bracket. Now isolate 4 times a by subtracting 12 to each side. Get a by dividing by 4. Therefore, a is 4. Some equations have variables on each side of the equal sign. First of all, expand the bracket. Solve this equation by rearranging all the variables onto one side of the equation and all numbers onto the other side. The easiest way to do this is usually by moving the unknown with the smallest coefficient in the equation. Decide which of the unknowns has the smaller number in front of it. Minus 2 is less than 8. So add 2 times b from both sides. Isolate the term 10 times b on the right-hand side by subtracting 7 to each side. Isolate b by dividing both sides by 10. Therefore, b is minus 1 over 10. In this case, we must expand the brackets as we did before. Solve this equation by rearranging all the variables onto one side of the equation and all numbers onto the other side. Subtract 24x from both sides. Subtract 14 from both sides. Isolate x by dividing both sides by 16. Some equations involve terms with fractions. To solve an equation with fractions, we transform it into an equation without fractions, which we know how to solve. The technique is called clearing of fractions. Clear of fractions as follows. Choose a common multiple of the denominators. You can see that 15 is the lowest common multiple. Therefore, multiply both sides of the equation by 15, every term by 15. Each denominator will divide into its multiple. We will have an equation without fractions. Expand the brackets. This equation is easily solved as follows. Multiply both sides of the equation by the lowest common multiple of denominators. Each denominator will divide into its multiple. Expand the brackets. If you are asked to solve a problem by forming an equation, you need to take the words and translate them into mathematics. Usually, once you get the math equation, you are fine. The actual math involved is often fairly simple. The hardest thing about doing word problems is using the part in which you need to take the words and translate them into mathematics. I will try to help you with some examples. However, to really learn how to do word problems, you will need to practice, practice, practice. What follows is a list of hints and helps. Addition, increased by, more than, in, combined, together, thought of, added to, greater than, sum, plus. Example. After reading, you should look for keywords. Certain words indicate certain mathematical operations. The sum of 8 in the number is 17. The keyword sum tells us that we must add the two quantities. A number increased by 4 gives 11. The keyword increased by tells us that we must add the two quantities. Subtraction, decreased by, minus, less. Difference between, of, less than, fewer than. Subtracted, smaller than. Example. Represent each situation using an equation and then solve the equation. A number less than 7 is 22. The keyword less than tells us that we must subtract the two quantities. A number decreased by 12 gives 51. The keyword decreased by tells us that we must subtract the two quantities. Multiplication, times, multiplied by, twice, triple, product of. Example. "68 is twice a number." The keyword twice tells us that we must multiply the two quantities. A number multiplied by 7 yields 91. The keyword multiplied by tells us that we must multiply the two quantities. division. Per divided by ratio of quotient of equal pieces split share. Example. The ratio of x and 5 is 105. The keyword the ratio of tells us that we must divide the two quantities. If a number is shared in 4 equal pieces yields 34. The keyword shared tells us that we must divide the two quantities. Now I will mix the mathematical operations in the next examples, and I will not spend much time on the solutions of the equations. A number is multiplied by 4. Then 7 is added to get 55. The sum of a number and 8. 3 times the sum of a number and 8 gives 162. Five more than a number is divided by 4 and then multiplied by 3 to give a result of 16. We can draw the following shape. The width is x, so the length is 40 more than its width. All the sides added together gives 350 meters. X, the current age. X minus 5, 5 years ago. X plus 5, the age she will be in 8 years. 5 years ago, Mary's age was half of the age she will be in 8 years. The current Anna's age is X. So in 8 years will be X plus 8. In 8 years, Anna's will be 3 times as old as she is today. X, Todd's age now. Sarah's age now is 3 times X. X minus 10, Todd's age 10 years ago. 3 times X minus 10, Sarah's age 10 years ago. Sarah is 3 times as old as Todd. 10 years ago, Sarah was 5 times as old as Todd. X, price each of one senior citizen ticket. Y, price each of one child ticket. First day, 3 times X plus 9 times Y is 75. Second day, 8 times X plus 5 times Y is 67. We get a system. So let's solve it.